In section P.5, titled Solving Equations Graphically, Numerically, and Algebraically, we're going to look at how to solve different types of equations utilizing our TI-84 graphing calculators. We're also going to focus mainly just on the graphical and the algebraic techniques to solving equations, and we're going to primarily look at just quadratic equations. Something we haven't studied yet this year, but everything that we do algebraically with quadratic equations, you have seen it before in a previous algebra course, so will be a little bit of review, and it's something we'll also hit kind of later in the course as well. First problem says solve the equation graphically and confirm algebraically. Now when we solve the equation graphically, we are wanting to sketch a graph of the equation and look to see where that graph crosses the x-axis. Where it crosses the x-axis, called x-intercepts or zeros, those are the points that we're interested in. Those are the solutions to the equation. So the first thing I do, I go on my calculator to the y equals button here. I'm just going to, if there's something typed in there, just clear it out, and I'm going to type in this equation. 2x squared minus 7x plus 3. And you can hit the graph button directly. Another way to get straight to the graph is to hit the zoom button. And I like to sometimes do this, hit the zoom button and choose standard. That will reset the windows so it is 10 all directions, 10 units all directions. So I want to know, where does this graph cross to the x-axis? I'm going to zoom in on this just so we're looking at the x-axis part. I'm going to do a zoom box. So I'm going to pull my cursor using the arrow buttons and just kind of highlight this part of the graph where it crosses through the x-axis. So what it's going to do, it's going to take that box and just blow it up and fill the entire screen. Okay, so there's my graph. What I want to know is, where does this graph cross the x-axis? Okay. Now we can look at this and guess that looks like 3, but it might be something really close to 3, so I need to find it exactly, and the calculator will do that for me. So I'm going to hit the second button, and I'm going to hit the calculate button right here, and I want to calculate the zeros. Now see, I've got a cursor here which I can move. It's a little X. I can move it left and right using the arrows. Let's find this one that appears to be at 3. The calculator tells me first, put the cursor on the left side. It wants a left boundary point. So I want left of that. So anywhere beneath here is left of that. Now it's going to ask me for a right boundary. So I'm going to move it anywhere to the right of that. Hit enter again. Now it's going to ask me to guess. I can move this around and guess if I want to, but I really don't even have to guess. I can just hit enter and it will calculate that. Notice it tells me that it is at x equals 3. I'm trying to solve this equation for x. That is one of my solutions. Now I do have another one over here. I want to find it too, so we'll just repeat all the steps. Second, calculate. I want 0. It's going to ask me for left side, right side again, so I got to trace all the way over to the left, go to the left of that 0, anywhere to the left, hit enter, go to the right, hit enter, guess, you don't even have to move it, just hit enter again. The other 0 is at 0.5. It's my other solution. So graphically, we got x equals 3 and x equals 0.5. Okay, now it says to confirm algebraically. And to confirm this algebraically, I need to solve this equation algebraically, so without a graph. And to do that, I'm going to solve by factoring, as it is a quadratic equation. Now we have reviewed factoring already this year. When I factor this quadratic, I'm going to use 2x times x. I need to multiply to positive 3 and add to negative 7. So I'm going to use a minus 3, minus 1. So the two negatives make positive 3. If I check the outside and the inside products, this one is negative 6. This one here is negative 1. Those add to -7, so that does work. Now we take each of these factors, set equal to 0, and we solve them for x. This one we add the 3, we get x equals 3. This one we add 1, divide by 2, we get 1/2. So my algebraic solution is identical to the graphical solution where we use the calculator to solve. The next few slides are going to take us through some algebraic ways that we can solve quadratic equations. A quadratic equation, remember, is a second degree equation. In other words, it has an x squared term, and it won't have an x to the third powered term or an x to the fourth. The x squared term will be the highest powered term that there is. Okay. Now, solving quadratic equations, we have a few techniques. Of course, we can use factoring. I say of course because we just did that on the last slide. So we can factor to solve them. Can't factor to solve all of them, but we can factor to solve some of them if it's a factorable equation. We have a technique called extracting square roots. We have a technique called completing the square. And we have a final technique called quadratic formula. I guess I shouldn't say final technique. We could also solve it graphically. As in the last slide, we did it graphically first, and then we factored it. But these four techniques, these are your algebraic techniques to solve quadratic equations. So we're going to go over, we've already gone over a factoring example, we're going to go over kind of some examples of these now, so you've seen them all. In this example, it says solve by extracting square roots. Typically what you see is you see a binomial that is being squared. What you do not want to do not FOIL this out. Okay, you're going to make the problem a lot harder than it needs to be. What we'll do instead is just eliminate the square from the very beginning of the problem, and we can eliminate the square if we do a square root to both sides. Square root takes out the square. The result is that we have 2x minus 3 equals plus or minus 4. Now, since we have the plus and minus sign, I need to continue to do steps to move the 3, move the 2. It'd probably be best at this point to kind of split this up into two problems. To solve now, 2x minus 3 equals 4, and 2x minus 3 equals negative 4. Both of them are going to have the same steps. I'm going to add 3 to both sides, giving me 2x equals 7, divide by 2, giving me x equals 7/2. That's an answer. We'll do the same steps over here. Add 3. So I've got 2x equals negative 1. Divide by 2 gives us x equals negative half. There's my square root technique. Typically, square root technique, that's the first step you're going to do, is just square root the equation and then create your two simpler linear equations to solve. I will say one thing about this here real quick is that the square binomial must be, I'll say, isolated first. Okay, what do I mean by that? Is we couldn't have 2x minus 3 squared plus something equals 16. If we had something else on this side that was added or subtracted to the binomial, I don't want to move it over first and then do all this stuff. Okay. This next example, completing the square, is a technique where I will create a trinomial that factors out of something that doesn't factor to begin with. You know, if I start, I cannot pick two numbers to multiply the negative 12 and add to positive 6. It doesn't factor. So what we're going to do is create a trinomial that does factor, and there's an easy way that we can do that. The first thing I like to do when I complete the square, though, is I'm going to isolate the x terms. So notice all I did is I took this minus 12 and I moved it to the other side, so it's a positive 12 over here. Okay. Now the way that I complete the square is this. We're going to add to both sides half of this number and we're going to square it. Half of 6 is 3, 3 squared is 9. Now what we have on the left factors. This factors x plus 3 times x plus 3, or x plus 3 squared. On this side we add these together, we get 21. Okay, so I began by creating something that factored. I was using a factoring technique. Now we're going to use a square root technique. Square root cancels the square. So we end up with x plus 3 equals plus or minus square root of 21. This is not a perfect square, and I can't take anything out. So I'm just going to leave it as it is. It's the best that it can be. I'm then going to subtract 3 from both sides. We end up with x equals negative 3 plus or minus square root of 21.